Hello, so for this recording we're going to solve the October-November 2024 variant 2 for pure 1, and let's get right into it. The first one, the diagram shows a curve with the equation y equals to a sine bx plus c for 0 to 2 pi, where a, b and c are positive constants. So what has happened here, this is a sine curve, yes, sine curve that has been transformed, and we need to find out what the transformations are. So whenever you're looking at a sine curve normally, you do know that it starts from the origin and then it goes something along these lines, where this period, which means the x for one revolution, this is 2 pi for normal sine curve, the amplitude, the height is 1, and the center is at 0. Yeah, and so those three things are the things we look for. And yeah, so for this one right here, we can see that the center, which is in between the top and the bottom, is right here. Okay, so that's where the center is. Then we see that the amplitude is this right here, and then obviously one revolution is gonna be pi instead of 2 pi. Yeah, 3 to 7, this is 4, and the center is at 3. And with this we can make our conclusion that there is a scale factor of 4 on the sine curve, right? So that means every y becomes 4y, because the scale factor of 4 stretch. And then obviously there is a stretch in the x direction as well. From 2 pi it becomes pi. That means we see that it has been stretched by a factor of stretched x direction by factor of half. But we know that when you're looking at curves or any functions, the x transformations are inversed, and so this just means x becomes the reciprocal of this times x, so this becomes 2x, right? And finally we have the center line being moved up by 3 units, therefore y equals y plus 3. Y becomes y plus 3. Center has been moved up from 0 up to 3, but we need to be very careful here that this happens before this happens, because if we did this first, it would have already stretched, it would have already moved to 3, and then we would stretch it by 4, the center would have been at 12, right? So we have to be very careful that this happens after the stretch. Okay, and with this we can see whatever happening with so we start off with sine x, this makes it 4 sine x, the y changing to 4y, and then what happens is x becomes 2x, so 4 sine 2x, and then y becomes y plus 3, so we just add 3 to this entire thing, so this just becomes 4 sine 2x plus 3. And so your value of a is 4, your value of b is 2, and your value of c is 3, and that's going to be your answer for this. Then for these values of a, b and c, determine the number of solutions in the interval for 0 to x to 2 pi for each of the following equations. So this right here equals to 7 minus x. So if we just draw this line on our graph, we will see how many solutions we have. So 7 minus x when x is 0, y is 7, okay? When x is pi, y will be 7 minus pi, which is just 3.85. so when x is pi, y is 3.85, yeah? And when y is 0, x is going to be 7, which is just slightly larger than 2 pi, right? And so we're going to have something along this line where it goes on, and it would reach it somewhere there. So how many solutions do we have for this? 1 right here, 2 right here, 3 right here, 4 right here, and 5 right here. So obviously the solutions are where they intersect, where these two intersect, right? And so we would have 5 solutions for this. And for this one, again, the same curve on the left, and now we just draw whatever's on the right. So 2 pi x minus 1, 2 pi x minus 1, and we could draw that line now. Let me just get rid of these points. And so basically when x is 1, or yeah, when x is 1, pi is, this is going to be 0. So when x is 1, which is somewhere about here, this is going to be 0. And then when x is 2 pi, so 2 pi minus 1 times 2 pi, this is going to be 33. So when x is 2 pi, it's going to be like somewhere 33. So let's go somewhere maybe closer. Pi, so when x is pi, pi minus 1, when x equals to pi, then this will just be 13. So when x is pi, this will be somewhere here. And so our line is basically going to start from somewhere below, and then it's going to go up like this. And here we only have one solution. Okay, we have one solution here. For this next part, we're told the first term of an arithmetic progression is negative 20. So an arithmetic progression starts from 20, and then the common difference is 5, sorry, negative 20. That means if you go from one to the other, you're going to add 5, you're going to get the next, which will be negative 15. Then you're going to add 5 again, you're going to get negative 10, and so on. Then you're told to find the sum of the first 20 terms. Now, sum of the first n terms equals to n over 2 times a plus a n minus 1 d. Meaning what? The first term and the last term. So first term and the nth term for that matter. So if you're looking at S20 equals to 20 over 2, first term, which is negative 20, plus negative 20 times n minus 1, which is just 19. Sorry, it's not times, this is plus. My mistake. So plus 20 minus 1, which is 19, times d, which is 5. And we can just do this. So equals to 10, open bracket, negative 40 plus 19 times 5, which is just 95. And 95 minus 40 is 55. And multiplied by 10, which is give you 550. So that's your sum of the first 20 terms. Okay? It's given that the sum of the first 2k terms is 10 times the sum of the first k terms. Okay? So S 2k, which is just 2k over 2, negative 20 plus negative 20 plus 2k minus 1 times 5. This is equal to 2 times, 10 times, right? The sum of the first 2k terms is 10 times the sum of the first k terms. So 10 times k over 2, open bracket, negative 20 plus negative 20 plus k minus 1 times 5. Yeah? And we just need to solve for k. So let's just do this here. The first one, k, open bracket, negative 40 plus 10k minus 5, right, equals to 10 k over 2, negative 40 plus 5k minus 5. Let's just open our brackets here. Negative 40k plus 10k squared minus 5k equals 10, open bracket, negative 20k plus 5 over 2k squared minus 5 over 2k. Yes, open the bracket again. Negative 40k plus 10k squared minus 5k equals negative 200k plus 25k squared minus 25k. And now we can just put them all on one side. So let's bring everything to the right. So 0 equals 25k squared minus 10k squared minus 200k minus 25k plus 40k plus 5k. Okay, and we're going to get 0 equals 15k squared negative 200 minus 25 plus 40 plus 5 is going to be minus 180k. And factor out k here like usual. 0 equals to k, 15k minus 180, and so k is either 0 or k equals to 15k minus 180 equals 0, so 15k equals 180 over 15 over 15, k will just be 12. And the question says that the sum of the first two k terms, meaning obviously we can't have the sum of the first 0 terms, and so this would just be our answer. So k equals 12. So for this next part, the equation of a curve is y equals to 2x squared minus 3. So y equals to 2x squared minus 3, and there are 2 points with x being 2 and x being 2 plus h. So point A, point B, this is 2 something and this is 2 plus h and something. Okay, and here what we need to do, we need to find and simplify an expression for the gradient of AB, right? So gradient of AB, we need y2 minus y1 over x2 minus x1. So we would need to find the y values for both of these. We just put that into the equation. So y equals to 2 squared minus 3, which is just 8 minus 3, which is 5. So here it's going to be 2, 5, and for 2 plus h, y equals to 2 plus h squared minus 3, right? And that's going to be 2, 4 plus 4h plus h squared minus 3, which is just 8 plus 8h plus 2h squared minus 3, which is 2h squared plus 8h plus 5. And that's going to be the y coordinate for here. So 2h squared plus 8h plus 5. Okay, then we can use this formula to find our gradient, which is just going to be 2h squared plus 8h plus 5 minus 5, yeah, over 2 plus h minus 2. And here what's going to happen, these two are going to cancel out, these two are going to cancel out, and we end up getting 2h squared plus 8h over h, which you can just change into two different fractions. So 2h squared over h plus 8h over h, and we end up getting 2h plus 8 as our gradient. Okay, now explain how the gradient of the curve at the point A can be deduced from the answer to part A and say the value of this gradient. Now for this we need to understand exactly what a gradient is. So suppose we had a curve, okay, and these 2 points right here, A and B, A x coordinate is somewhere here, so at 2, yeah, at 2, and the y coordinate is somewhere here, so at 2 plus h for some value of h. H is some random value, right? We don't know what h is, but what happens is, and we found the gradient of this thing right here. Now this is not quite the tangent, but if h was smaller, right, if h was smaller, maybe h was so small that 2 and 2 plus h are right next to each other, and we drew our chord, we're going to get something more like a tangent. And basically the closer 2 plus h is, the closer 2 plus h is to 2, right, the better our tangent gradient would be. In fact, as h approaches 0, meaning as 2 plus h becomes 2, for this to happen you need h to become 0, so the distance between 2 and 2 plus h becomes smaller and smaller, right? As h approaches 0, the chord, you're drawing the chord, remember for a chord you just need 2 points, and if those 2 points are very, very close together, you're going to get a very good estimate of what that line would be at the point 2. And so as h approaches 0, that AB as h approaches 0, AB will become tangent of the curve at A, because it gets extremely close to the point 25 at A, and we would get the line that just touches 25, and so we would get the gradient at that point. So we just need h to approach 0 from this, so 2h plus 8. As h approaches 0, this will just become 2 times 0 plus 8, and so the gradient would be 8 at the point A, right? This is A. Okay. Next, find the term independent of x in the expansion of the following: x plus 3 over x squared power 6. So obviously the formula binomial expansion is NCR, the first term power n minus r, the second term power r. N in this case is 6, so let's just replace that. And so we would now need to find the value of r. How do we find the value of r? We need this to equal something x power 0, because we want it to be independent of x, meaning we don't want to have x, which just means we want the power of x to be 0, right? And so to find what r is, we would have to use this knowledge right here. Obviously you could go through the whole r equals to 0, r equals to 1 up to 6. That would take too long, and so this is a shortcut to it, because you just need a specific expansion value, right? And from this we can go to we just use the first x term, so x power 6 minus r. Then obviously you are multiplying it by the second x term, so x power negative 2, yeah, I brought it up, power r, and if you multiply them you want to get x power 0. So I'm just dealing with the x powers right now in order to get r. So this becomes x power 6 minus r times x power negative 2r equals x power 0. Remember, if you're multiplying two numbers that are the same with different powers, you add the powers. And so x power 6 minus r plus negative 2r, which is just x power 6 minus 3r equals to x power 0. And so 6 minus 3r is equal to 0, where 3r equals to 6 and r would be 2. And now you can just plug in 2 here, and that would give you your answer for this. So this would just be 6 minus 2, which is 4, and this right here would be 2. And if you find that, you're going to get your answer. So 6 combination 2 is just 15. So 15 times x power 4 times 3 squared over x power 4, x squared squared, right? This will cancel out, and you end up with 15 times 9, which is just 135. And that's going to be your term that is independent of x, the one that does not have x. Okay. Next part, now we are having two multiplications. We're multiplying this thing by this thing, and so we want to find, after we multiply them, how can we get x power 0? After we multiply the term from here with this, how can we get x power 0? So obviously we would have to multiply it by this term and by this term, right? And for this one, it's quite simple, because if something does not have x from this expansion right here, and you multiply it by a constant which is negative 5, it's not going to have x again. And so from this expansion we are interested in x power 0, and if we had x power 3, we want to multiply something to x power 3 to give us x power 0, we would be multiplying x power negative 3, because if I multiply any x power negative 3 with x power 3, I'm going to get x power 0. And so what I'm interested in from this expansion is the term for x power negative 3. And so we can find that again. We can use this same formula. Now instead of being interested in x power 0, we're interested in x power negative 3. And so x power 6 minus 3r equals to x power negative 3, which just means 6 minus 3r equals negative 3. Take this to this side, take this to this side. So 9 equals 3r over 3 over 3r equals 3. Okay, and we can just use that. So 6 c 3 x power 3, so 6 minus 3, and 3 over x squared power 3. And what we do get here is 6 combination 3, which is 20, so 20 times x cubed times 3 cubed is 27 over x power 6. And what happens here is this becomes x power 3, which gives us x power negative 3, which was what was desired, right? So 20 times 27 is just 540, so 540 x power negative 3. So from this expansion right here, the one with the power, we have gotten two terms, one from the a part, which is 540 x power negative 3 plus 135. Those are the only two things we're interested in, because once we multiply it with this, we are going to get our x power zeros. So 4x cubed minus 5 times 540 x power negative 3 plus 135. We're interested in this multiplication, and we're interested in this multiplication. And so we can just do those. So 4x cubed multiplied by 540 x power negative 3 plus 135 times negative 5. And these will cancel out, because x power 3 times x power negative 3 is just x power 0. And so 4 times 540 is 2160, and 135 times negative 5 is negative 675. And if we add these two together, we're going to end up with 1485, which is the term independent of x in this question. Okay. The next part asks us about a function. So the function f is defined by f of x equals to 2x plus 1 over 2x minus 1 for x less than a half. So any value less than a half, that's the restricted domain on this function. State the value of f of negative 1, which means x in this case is negative 1. So you just put that here, 2 negative 1 plus 1 over 2 negative 1 minus 1, which is negative 2 plus 1 over negative 2 minus 1, which is just negative 2 plus 1 is negative 1 over negative 3, which is just 1 over 3. So f of negative 1 equals 1 over 3. Okay. So for this next part here, the diagram shows the graph of y equals to f of x, and we have to sketch the inverse of it, and we need to show any relevant mirror line. So if you guys know f of x with f inverse of x, these are just reflections of each other along the mirror line of y equals x. That's your mirror line that it's a reflection of. And so first we need to draw our mirror line, obviously, and so this is gonna be the points of our mirror line, yeah, because it is y equals x. So when y equals 4, x equals 4, and so on. So let's just draw that right here. Then we can start drawing our points, meaning let's just start off with this one. So this right here is negative 4 and about 0.8, right? And if we reflect it along this line y equals x, meaning the x and y switch places, which means on the other end we're going to look for 0.8 with negative 4, which would be somewhere here. Okay, so that's the first point. Let's look at the intersections as well. So this right here is just 0 with negative 1, and so we're going to switch them around. This will become negative 1 0, so y equals x and x equals y. So our this point right here will move here, okay? And then our other intersection, which is this thing right here, is just negative 0.5 for x, and for y it's going to be 0, and so we're going to switch them around to 0 and negative 0.5, and so this would just come 0 and negative 0.5. Yeah, and finally the last point, the last point is the ending point. So this one right here, this one, the coordinates of this are about 0.2 with negative 4. Yeah, I'm just estimating the x value, and so these are going to switch up to negative 4 with 0.2, and so the x value will become negative 4, and the y will become about 0.2. and these 3 dots, if we join them, we're going to get our mirror line. It's going to look something like this. And so this right here, y equals to f inverse of x. So we always just switch the y and the x values. Okay, and yeah, that's about it for this part. So to sketch the inverse, we need to draw our mirror line y equals x, and then just switch the x and the y for a few points until we can see what the curve would look like. Okay. Then for the next one, the function g is defined by g of x equals 3x plus 2, and solve the equation f of x equals to g f of 1 over 4. So f of x equals to g f of 1 over 4. So for this we need to find what f1 over 4 is. We can go to our graph, and 1 over 4 is just about here, right? And we get that 1 over 4 is negative 4. Or we could just use the equation 2x plus 1 over 2x minus 1, 2x plus 1 over 2x minus 1, and we want x to be 1 over 4. So 2 times 1 over 4 plus 1 over 2 times 1 over 4 minus 1. This will become half plus 1, which is 3 over 2. This will become half minus 1, which is negative 1 over 2. And that's just going to be negative 3. And then we can put that negative 3 into the g function. So g of negative 3, which is equal to 3 times negative 3 plus 2, which is negative 9 plus 2, which is negative 7. Then we have to solve f of x equals negative 7. What value of x will give us negative 7? So just put that again, 2x plus 1 over 2x minus 1 equals negative 7. Bring that up here. And 2x plus 1 equals negative 14x plus 7. Multiply this with this, and we can just rearrange them. So we get 16x equals 6 over 16 over 16. X would be equal to 6 over 16, which is just 3 over 8. And that's what x would be equal to. Just quickly right here, I forgot to state the domain of the function of inverse. So the domain of the inverse is just equal to the range of the original function. And if you see the original function, the range is everything below. So obviously this would go on forever, but it would never cross this line. This is the asymptote of it. That means the range of f, the original function, the one that's in black, is just f of x is less than 1. It never really touches 1, right? Because that's an asymptote. And so the domain of f inverse of x would also be less than 1. So the same thing. So that means x less than 1 is the domain for f inverse. Okay? Let's look at the next question here. They've given us a complicated plate, we could say. And so there is one sector right here with the radius of 2r, right? And angle of 2 theta. And then the smaller sectors with radius of r and angle of angle of theta again, sorry. So angle of theta, 2 of them, and there's one with angle of 2 theta. And it is given that the perimeter of the plate is 14. So for perimeter, you want to find this thing right here, okay? And then you want to find these 2 arcs, and then you're adding this, 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 and this, okay? So these lengths are obviously r because this thing right here is gonna be r as well, and 2r minus r is just r. And so for the perimeter, we are looking at r plus r plus r plus r. So these 2 r's and these 2 r's, so 4r. And then we want to add this bigger arc length and these 2 smaller arc lengths. So obviously arc length is just r theta, and so this, for the larger sector, the r is 2r. So 2r times theta, which is 2 theta, which is just 4r theta. That's the arc length of the bigger one. And for the smaller one, r theta, which is just going to be r theta, you have 2 of those arc lengths, so times 2, which is 2r theta. So at the end of it, the perimeter will equal to 4r plus 4r theta plus 2r theta, which is just 6r theta. So perimeter, which is 14, equals to 6r theta plus 4r. Okay. Then when you're looking at the area, obviously area, you just find the area of the larger sector and the area of the 2 smaller sectors. So for area, half r squared theta. So for the larger one, half r is 2r squared times theta is 2 theta, and for the smaller ones it is half times r squared times theta and then times 2, because there are 2 of them. Yeah. And so the area is going to be half times 4r squared times 2 theta, which is just going to be 4r squared theta. So we have 4r squared theta plus r squared theta, which is just 5r squared theta, which is the area of this shape, and this is going to be the perimeter of that shape. So 5r squared theta equals 10, and we have that 6r theta plus 4r equals 14. Here we could just make one of them the subject. So let's just make theta the subject. So we divide by 5r squared on both sides for this one, and that's going to give us theta equals 10 over 5r squared, which is just 2 over r squared. So theta equals 2 over r squared. We can substitute that into the next one. So 6r 2 over r squared plus 4r equals 14. This is going to be 6 times 2, which is 12, over r. I cancelled these out, yeah, plus 4r equals 14. And then we can just multiply by r both sides, and we're going to get 12 plus 4r squared equals to 14r, and that's just a quadratic equation. So 4r squared minus 14r plus 12 equals 0, and we can solve for r here. And our 2 values of r are going to be r equals 2 and r equals 3 over 2. Okay, and from that we can find what our r will actually be. So he said that r is greater than 3 over 2, which means it can't be 3 over 2, and so r is going to be equal to 2. And with that r we can find our theta. So theta equals 2 over r squared, which is just 2 over 2 squared, which is just 2 over 4, equals to a half. And so our theta will be a half, which does go in line with this restriction. It is lesser than 3 over 4. And so our r equals 2 and our theta equals a half. That's going to be our answers. For the next part, by expressing negative 2x squared plus 8x plus 11 in this form, which is the completing the square form, where a, b, and c are positive integers, find the coordinates of the vertex of the graph with equation y equals to negative 2x squared plus 8x plus 11. So for this, we need to obviously first factorize the negative 2, because remember, to use the formula x plus b over 2 squared minus b over 2 squared plus c, we need a to be 1. So here a is not 1, so we need to factorize a first. So negative 2 x squared minus 4x minus 5.5. Yeah, so I factored out, and now inside here a is 1. So negative 2, put in our bigger formula, so x minus 4 over 2 squared minus negative 4 over 2 squared minus 5.5. Yeah, and this will just become negative 2 on the outside, x minus 2 squared. This is just going to be negative 2 squared, which is 4 times negative, so minus 4 minus 5.5, which is just going to be negative 2, open bracket, x minus 2 squared, negative 4 minus 5.5 is negative 9.5 times negative 2, so negative 2, negative 9.5. Yeah, so at the end, negative 2, x minus 2 squared, and that's going to be plus 19. And our vertex, remember, is the negative version of this, so negative of negative 2, which is just 2, that's the x coordinate, and the y coordinate is just whatever's on the outside. Yeah, so our vertex is going to be 2, 19. That's going to be our vertex. For the next part, the diagram shows the curve with the equation y equals to negative 2x squared plus 8x plus 11, and the line with the equation 8x plus 9. And they want to tell us to, they're telling us to find the area of the shaded region. So basically the shaded region is between these 2 points, so their intersection, which firstly area under the graph, because you're finding area of a curve, so area under the graph where you have to integrate, right? And obviously you integrate throughout limits, and your limit points will be this and this, right? So on your integral, the a and b you will get from these 2 intersections. And then what you want to do is, obviously you can't just find the area of the shaded part alone, and so the whole concept is that we would find the area under the graph of the curve, so the higher one, so this line right here, minus the area under the graph of the line, so minus the area under the graph for this line. And so we're going to end up with, first we need to find the intersection points. So negative 2x squared plus 8x plus 11 equals to 8x plus 9. Let's see what happens here. 8x and 8x goes, because if you take it to the other side it will just cancel out. And so let's take this here. So negative 2x squared equals 9 minus 11, which is negative 2, over negative 2 over negative 2. X squared equals 1, and so x equals positive 1 and x equals negative 1, and those are our 2 limit points. And so we end up getting negative 1 with 1, and our equation is just the curve subtracted by 8x plus 9. So negative 2x squared plus 8x plus 11 minus 8x plus 9. And we're going to end up with negative 1, 1, negative 2x squared, 8x minus 8x is 0, 11 minus 9 is just 2, so plus 2. And we're just going to have to integrate this. And if you integrate this, we end up getting plus 1 over, so negative 2x power 3 over 3 plus 2x. And our limit points are 1 and negative 1. So we just put those in. Negative 2, 1 power 3 over 3 plus 2, 1, subtracted with negative 2, negative 1 power 3 over 3 plus 2, negative 1. And we will just find this. And this becomes negative 2 over 3 plus 2 subtracted by positive 2 over 3, because negative 1 cubed is just negative 1 times negative 2 is positive 2 over 3 minus 2. And so this gives us 2 divided by 3. This gives us 4 over 3, and we're going to subtract it by negative 4 over 3, which is just going to give us 8 over 3. And that's going to be our area under the graph for that question. Next part, the equation of a circle is x squared plus y squared plus px plus 2y plus q equals 0, where p and q are constants. Express it in this format, where a is given in terms of p and r squared is also given in terms of p and q. So remember, if you have an equation like this and you want to change it into this format, we need to complete the square for x and we need to complete the square for y. And so x plus p over 2 squared minus p over 2 squared, right? And then we're going to do the same thing for y. So y plus 2y, sorry, y plus 2 over 2 squared, y plus 2 over 2 squared minus 2 over 2 squared. And then you have your plus q at the end equals 0, right? Let's just do this here. So x plus p over 2 squared minus p squared over 4, and then here is going to be plus y plus 1 squared minus 1 plus q equals 0. This is going to be our this part right here. This is going to be our this part right here. And our r square, we just take everything that's remaining to the other side. Yeah, and we end up getting x plus p over 2 squared plus y plus 1 squared equals p squared over 4 plus 1 minus q. And so our a is just negative p over 2, and our r squared is p squared over 4 plus 1 minus q. Yeah, and then the line with the equation x plus 2y equals 10 is a tangent to the circle at the point 4, 3. Find the equation of the normal to the circle at point A. So what they're telling us here is that we have a circle and we have a point A which is 4, 3, and we are told that this line right here, which is x plus 2y equals 10, is the tangent at that point, and we just need to find the normal of the circle at that point. So the normal goes obviously from the center, because it's the tangent, the normal of the tangent is at the center. So we're going something like this, and we're told to find the equation of this line right here. Okay, so for this, remember these two are perpendicular, the tangent and the normal, and so we could find the gradient of the tangent. We'll find that instantly actually. X plus 2y equals 10, 2y equals negative x plus 10 over 2 over 2 over 2, which is y equals to negative 1 over 2x plus 5. So our gradient for our tangent is negative a half. With that, we can find the gradient of the normal. How? m1 m2 equals negative 1, so negative a half times m2 equals negative 1, which just tells us that m2 equals 2. And so the gradient of our normal is 2, so y equals to 2x plus c, where we can put in our points that it crosses, which is 4 and 3, which will just become 3 equals 2 times 4 plus c, 3 equals 8 plus c, 3 to the other side, c equals negative 5. And so the equation of the normal will be y equals to 2x minus 5. That's going to be the equation of the normal. And then we can find the values of PQ. So obviously we know that that the center is just AB from this. So the center for the circle is going to be negative P over 2 and negative 1 is a y, negative 1, right? And the radius is just the square root of this entire thing. So center is negative P over 2 and negative 1, and the radius is the square root of P square over 4 plus 1 minus Q. P square over 4 plus 1 minus Q. And obviously that radius is going to be the distance between this and this. Yeah, and also the center lies on this line right here. Meaning what? So if I just put my y value, negative 1 here, so y equals to 2x minus 5. If I put my negative 1 here as my y, I'm going to get my x, so equals to 2 negative p over 2 minus 5. It's just going to be negative 1 equals negative p minus 5, which will just become p equals negative 5 plus 1, so p equals negative 4. And so what we see here is that we use the equation of the normal, because we know the normal passes through the center. We use the equation of the normal, which was 2x minus 5, to find what p was, because we already had that the center has a y coordinate of negative 1, right? And so we put that negative 1 into this line, and we got our x value, which was negative p over 2, which in this case is gives us p equals negative 4. Okay, so our center is just negative of negative 4 over 2 and negative 1, which is just 4 over 2, which is 2. That's our center for the circle. Now all that's required is to find the radius. The radius is the distance from the center to any point on the circumference. So from 2, negative 1 up to 4, 3, the distance between this is gonna be our radius. Yeah, and so we can use both these informations to basically find out the radius. So from the distance formula, we have that the radius is the square root of x1 minus x2 squared, so 2 minus 4 squared plus negative 1 minus 3 squared. Yeah, and we're going to get the square root of negative 2 squared, which is 4. And here we're going to get negative 4 squared, which is 16, so plus 16 is equal to square root of 20, right? And that radius is going to equal to this right here. So root 20 equals root p squared over 4 plus 1 minus q, which just means 20 equals to p squared over 4 plus 1 minus q. We have our p, which was negative 4. So 20 equals to negative 4 squared over 4 plus 1 minus q. 20 equals to 16 over 4 plus 1 minus q. 20 equals to 4 plus 1 minus q. So 20 equals to 5 minus q. Take this to the side, take this to the other side. Q will just be 5 minus 20, which is negative 15. So my p is negative 4, my q is negative 15. And those are going to be our two values for p and q. Okay. For this question, the equation of a curve is y equals to half k squared x squared minus 2kx plus 2. And the equation of a line is y equals to kx plus p, where k and p are constants and k is between 0 and 1. It's given that one of the points of intersection of the curve and the line has a coordinates of 5, 2 and a half, which means that this point right here exists on the curve and the line, because if this was the curve and this was a line and one of the points is 5 over 2 and a half, this just means that this is part of the curve. It's a point on the curve, and we can use that information from here. So the curve is y equals to half k squared x squared minus 2k x plus 2, and we can just put these points in and we will be left with the variable of k alone, and we can find k from that. So y is a half equals to a half k squared x squared, which is just 5 over 2 squared, minus 2k 5 over 2 plus 2. Okay, and then we get a half equals to a half k squared times 25 over 4 minus 5k plus 2. And then what we can do here is just multiply this in. So half equals to 25 over 8k squared minus 5k plus 2. And I want to remove the denominator because that's a bit annoying. So times 8 on both sides. We end up getting 4 equals 25k squared minus 40k plus 16. Subtract 4 on both sides. We end up getting 0 equals to 25k squared minus 40k plus 12. And we could solve this, and we would get k equals to 1.2 or k equals to 0.4. We were told k is between 0 and 1, and so we are going to use 0.4 and not 1.2. And with that we can get our equation of the line. I mean, we can get the k part of it at least, where y equals to 0.4x plus p. Now that we have gotten k, we can use that to find p as well, because we know that this point is also on this line. So half equals 0.4 times 5 over 2 plus p. So half equals to 1 plus p, and so p would equal to negative a half. And so we have now both equations in full. So y equals to 0.4x minus a half for the line, and y equals to half k squared. So half times 2 over 5 squared x squared minus 2 over 5 times x plus 2, which just gives us y equals 2 squared, which is 4 over 25. So 2 over 25 x squared minus 4 over 5x plus 2. and we have our two equations right there. So y, and remember we want to find the other point of intersection, and for that we need to do simultaneous equations. So y equals y, and so we end up getting 0.4x minus a half equals 2 over 25x squared minus 4 over 5x plus 2. We want to get rid of the denominators, so we multiply 25 throughout, and we end up getting 10x minus 12.5 equals to 2x squared minus 20x plus 50. And let's just rearrange them a bit, and so 0 equals to 2x squared minus 20x minus 10x is minus 30x, and then plus 62.5. Take this to the other side, and we can solve for x here to negative 30 and 62.5. We end up getting x1 equals 25 over 2, x2 equals 5 over 2. We already have this point from the one that they gave us. X is 5 over 2, and so this is our other point of intersection, and with this we can find the y value for this as well. Y equals to 0.4x minus a half, y equals to 0.4 times 25 over 2 minus a half, so y will equal to 0.4 times 25 over 2, which is just 5 minus a half equals to 4.5. So the other point of intersection is x 25 over 2 and y being 4.5 or 9 over 2. Yeah, and that's going to be it for this question. It is now given that the line and the curve do not intersect. Find the set of the possible values of p. So let's just write our two equations again. Remember, we already had k. K was 0.4, and now we just need to know what p is. So when k is 0.4, we get our equation, which is y equals to 0.4x plus p, that's the line, and y equals to the equation of the curve was 2 over 25x squared, 2 over 25x squared minus 4 over 5x plus 2, minus 4 over 5x plus 2. And you don't want them to intersect, so that means you want to make it simultaneous and then make the discriminant less than 0 to find the values of p. So equate them like simultaneously, so 0.4x plus p equals to 2 over 25x squared minus 4 over 5x plus 2, and we can put these together. So 0 equals to 2 over 25x squared minus 4 over 5x minus 0.4x plus 2 minus p. Yeah, and here we can just multiply by 25 throughout so that we can get rid of the denominators. This would give us 0 equals 2x squared minus 20x minus 10x plus 50 minus 25p. Okay, and here we would get 0 equals to 2x squared minus 30x plus 50 minus 25p. And with this we can find our discriminant. This is going to be our c, this is going to be our b, and this is going to be our a. So b squared minus 4ac, we want it to be less than 0 because we don't want it to intersect, right? So negative 30 squared minus 4, a is 2, c is 50 minus 25p, less than 0. This is going to be 900 minus 850 minus 25p. So 900 minus 400, and then negative 8 times negative 25 is just 200p. We want this to be less than 0 again. So this will become 500 plus 200p less than 0, which will just be 200p is less than negative 500 over 200 over 200. P should be any value that is less than negative 5 over 2. As long as this happens, the curves will never intersect. In this case, we got p to be negative a half, which is greater than negative 2.5. That's why we got points of intersection. So for this question, a function f with domain x greater than 0 is such that the f prime of x, which is just dy dx, is equal to 8 times 2x minus 3 power 1 over 3 minus 10x power 2 over 3. It's given that the curve with the equation y equals to f of x passes through the point 1 and 0. We need to find the equation of the normal to the curve at the point 1 and 0. So we basically, so the normal to the curve, meaning that normal line is perpendicular to the tangent, and obviously you know the tangent gradients multiply to give you -1, and the tangent gradient is given by the dy dx, which is the f prime of x. So we can use this with our x value of 1 to find the gradient at that point, right? So 8, 2, 1 minus 3 power 1 over 3 minus 10, 1 power 2 over 3. That gives us our gradient of our tangent. This will be 8 times -1 power 1 over 3 minus 10, right? And this thing right here would just be -1. The cube root of -1 is -1, so 8 times -1 minus 10, which is just -18. That's our gradient of our tangent. So the gradient of our normal will be -18, m2 equals -1. m2 will just be 1 over 18 positive, right? And then we can have y equals to 1 over 18x plus c, passes through this point, and so 0 equals to 1 over 18, 1 plus c, so c is just equal to -1 over 18. So y equals to 1 over 18x minus 1 over 18, or we can just multiply 18 throughout. We're going to get 18y equals to x minus 1. That's going to be our equation of the normal. Yeah. To find f of x, remember this is like dy over dx, the f prime of x. So to get back the original equation, we would integrate it. So we integrate this right here, 8 2x minus 3 power 1 over 3 minus 10x power 2 over 3. We would integrate this without limits. Yeah, that means we would get a plus c. But to integrate this, we would need to do some substitutions. So we could substitute this thing right here as u. So 2x minus 3 equals u. And remember, because there is a subtraction between, we could just split the integrals as well. So 8 2x minus 3 power 1 over 3, and then minus 10x power 2 over 3. And so here du will equal to 2 dx. So dx equals to du over 2. These are both dx, by the way. Yeah. And here we're going to end up getting 8u power 1 over 3 du over 2 minus 10x power 2 over 3, which can do directly. Right, so this is just going to become 4u 1 over 3 plus 1 over 1 over 3 plus 1 minus 10x 2 over 3 plus 1 over 2 over 3 plus 1. And then you have your plus c at the end. This is going to become 4u power 4 over 3 over 4 over 3 minus 10x power 5 over 3 over 5 over 3. Then you're going to have your plus c at the end, right? Your u is 2x minus 3, so we can just substitute that back. So 4 2x minus 3 power 4 over 3 over 4 over 3 minus 10x power 5 over 3 over 5 over 3 plus c. This is your y, your equation of the, or this is your fx for that matter, right? We could just simplify this. So 4 divided by 4 over 3 is just 3. So 3 2x minus 3 power 4 over 3, and then 10 divided by 5 over 3 is just 6. So minus 6x power 5 over 3 plus c equals to f of x. Remember, this passes through the point 1 0, and we could just substitute those in to find c. 0 equals to 3 2 1 minus 3 power 4 over 3 minus 6 1 power 5 over 3 plus c. This is going to be 0 equals 2 times 1 is 2 minus 3, it's negative 1. So 3 negative 1 power 4 over 3 minus 6, 1 plus c. This is just going to be, you cube root negative 1, you're going to get negative 1, and then you power that by 4, you're going to get positive 1. So 0 equals to 3 times 1 minus 6 times 1 plus c. 0 equals to negative 3 plus c. C will equal to 3. And so our equation of that curve, of our function f of x, will just be 2x minus 3 power 4 over 3 minus 6x power 5 over 3 plus 3, because that's our c. That's going to be our function f of x. For this final part, it says it is given that the equation f prime of x, which we found above, was f prime of x, which was, not found above, but it's given in the question, 8 2x minus 3 power 1 over 3, and then minus 10x power 2 over 3, 10x power 2 over 3. That we need to make it equal to 0, and we have to express it in that form, right? And so we could firstly just take this to the other side. So 8, this would make it 8 2x minus 3 power 1 over 3 equals 10x power 2 over 3, and we could just remove the power 1 over 3s by powering 3 on both sides. This would make it 8 power 3, which is 512, 2x minus 3, and obviously the power 1 over 3 goes away because you're powering by 3, equals 1000 x squared. And we could just multiply out here, which will become 1024x minus 1536 equals 1000 x squared. And if we simplify this, so divide by 8, divide by 8, divide by 8. Why do I know it's divided by 8? Because I just saw this 125x squared, and I have 1000x squared here, and to get 125 from 1000, I'll just divide by 8. This would give us 125x squared equals 1024 divided by 8, which is 128x, and 1536 divided by 8, which is 192. And if we rearrange this, 125x squared minus 128x plus 192 equals 0, which is what we had to find. So that's what we have already shown that this is it. And now we just need to show whether it's an increasing, decreasing, or a neither function. Increasing means f prime of x is greater than 0 for all values of x in the domain. Decreasing means f prime of x is less than 0 for all values of x in the domain, while neither means it can be increasing in some parts and decreasing in other parts. So with this first, let's try to see if there is any points at which dy dx, which is the f prime of x, which is the gradient, equals to 0. Now usually this shows a change in your gradient, right? So if you had a point where your gradient is 0, you could say that at that point is when it went from a positive to a negative gradient. And if we try to find the solution for this, you will see that you won't get any solutions. Yeah, there won't be any solutions for this equation right here, which means there is no turning point in the original equation. This equation does not have a turning point, which means the gradient is either always positive or always negative. So this is just taken away because it can't just suddenly change, right? So it's either always positive or always negative. Now how do we find which one of that it is? For that, we could just take any point in the domain. Yeah. So domain is x is greater than 0. So let's just take the point 1 and put it into our f prime function. So 8 2x minus 3 power 1 over 3 minus 10x power 2 over 3. Let's just put x equals 1 and let's see what happens. 8 2 1 minus 3 power 1 over 3 minus 10 1 2 over 3. This will give us 8 negative 1 power 1 over 3 minus 10 1 power 2 over 3, and that will give us our f prime of x. This will just be 8 times negative 1 minus 10, which is negative 18, which we did find above as well. But so here our gradient was negative, and because there is no turning point, the gradient never changes sign. And so if we get one point in the domain to be negative, we can make the conclusion that for every point, so every x greater than 0, every point in the domain, f prime of x will always be less than 0, which tells us that it is a decreasing function. Okay, and that is it.